Hey everyone, a very good evening. Welcome back to my channel. My name is Akriti. I hope you all are doing well. So let's start with the today's question. This is the question number 2076, process restricted friend request, right? So in this question, basically we are given an integer n, which is denoting the number of people we have in our network, right? So each people is labeled as from 0 to n minus 1. So total we will be having n peoples, right? Now we are given a 2D array restrictions where the restriction of I is equal to a vector of element 2, which simply mean a person X cannot become friend with person Y, right? Or opposite, you can say a person Y cannot become friend with person A, anything that suits you. So either directly or indirectly. Now, what do they mean by saying indirectly? So let's suppose if A is a friend of B and B is a friend of C, right? So A will also be a friend of C. This is called indirect friends, right? So they are saying it is not allowed for X and Y to be a direct friend or indirect friend. Nothing is allowed. Now, if they are in the restrictions are in. So initially no one is friend of no one. Initially it is like this. And now we are given a list of friend requests which are available with us. So a request of J simply mean UJ and VJ want to be a friend, or there is a friend request between the two persons which is U and J, V's, right? So these are the two person U and V and they want to be friend. Now um, a friend request is successful if you and we can be friends and each friend request is processed in the given order. Like in the order we are given the request, we have to process the request in the same order, right? So we have to tell if you and J, if it is possible for you and J to become friend, because they should not violate any condition which is given in the restriction, right? Like let's suppose in this example it is given the restriction that 0 and 1 cannot become friend, right? So if we are processing the request which we are given here, so we have to make sure that we are not violating any restriction, like you should, like 0 should never be friend of 1, right? So we have to make sure we are not violating any restriction, and then only we have to process our request, and we have to return true or false on the basis of either 0 and 2 can become friend or they cannot. Here 0 and 2 could become friend, that's why we have returned true, and here 2 and 1 cannot become friend, that's why we have returned false, right? So if U and J are already direct friend, then the request is still successful, right? So this is something. Now let us consider the people here, which is denoting from 0 to n minus 1. Let us consider these are the nodes of a graph, and let's consider the requests which are there as a kind of graph. Okay, so let me explain you this example. Okay, so this is the example which we will be understanding here. Okay, so this is the restriction vector here. Restriction of 0 to 1 simply means 0 cannot become friend of 1, or 1 can never become friend of 0. Similarly, 1 cannot become friend of 2. Similarly, 2 cannot become friend of 3, and so on, right? So these are the restrictions which we have to keep in mind while processing our request. Okay, so this is the very first request which we have. Now these are the number of people which we were there in the question, and we are considering them as a nodes of a graph. So this is a graph, and initially no one is friend of no one, right? So there is no connection between any of the given peoples, right? Now let's consider this particular request which is saying 0 want to become friend of 4. Okay, so let's suppose I just say, yeah, I am going to process this request and I will make a connection between 0 and 4, right? Okay, now I have to check if this connection is violating any restriction or not, right? Because we have to make sure that restrictions should not be violated, right? So now we will go through the all the restriction and we will check if it is violating my restrictions or not. So let's move to the first one. It is saying 0 should never be a friend of 1 either directly or indirectly, right? So here 0 and 1 are not connecting either directly or indirectly. So it is not possible for 0 and 1 to be friend after making this particular connection. So yeah, this restriction is following. Now move to the second restriction. 1 should not be friend of 2. So here also you can see 1 and 2 are totally different components, right? So they cannot be friend. Now move to the third request, sorry, restriction, which is saying 2 should not be friend of 3, right? So here also you can see 2 is 2 and 3 are both in the different components, so 2 cannot be friend of 3. So here we can see we were able to process this request, and here we will be returning true for this particular request, right? Now let's move to the second request. Okay, so this was about the first request. Now let's move to the second request. Second request is saying one want to be the friend of 2, right? So let's suppose I just connect it. 1 is a friend of 2. Again, check for the restrictions, right? Now the first restriction is saying 0 should not be friend of 1, so here 0 cannot be friend of 1 because both are in different component. Now here you should know that in a graph, if we are talking about the connection, then if two nodes are in the same component, then you can reach from one node to another easily, right? If this is an undirected graph, right? So we are talking about that only. So if they are on the same component, only then they are reachable, otherwise not, right? So here 0 and 1 both are in different component, you can see. So they are not reachable, or simply you can say they cannot be become friend of each other. So this restriction is okay. Now the second one is saying 1 should not be a friend of 2, right? So here you can see this was the connection we just recently made, which is showing that 1 is a friend of 2. So simply we can see this particular request is violating a restriction. So we cannot process this request, right? So we will need to delete it. And let's say this is not allowed. So here we will be returning false for this particular request. Now let's move to the next request. This is the 3 comma 1. So 3 want to become friend with 1. So let's make a connection between 3 and 1. Okay. So this is the connection between 3 and 1. Now I'll check for the restrictions, right? From the very first, 0 should not be friend of 1. Okay, 0 is not friend of 1. Now 1 and 2, so there's no connection between 1 and 2 and 3. So yeah, there's no connection between 2 and 3. So this particular request is not violating any restriction. So yeah, we can say this request is valid. So here we will simply return true. Now let's move to the last request, which is 3 comma 4. Now let's observe here what we are actually doing here, right? So 3 comma 4. So once I make this particular connection 3 comma 4, okay, so this is the connection which I made. Now just see, for the first restriction 0 should not be friend of 1. So here you can see now after making this connection 0 and 1 are friend of each other, or you can say they are indirect friend of each other, right? Because indirectly we can reach from 0 to 1, right? So basically they are indirect friend of each other. So this particular request is violating our our restrictions, right? So we cannot process this request, so you'll need to delete it, or you will simply return false here. So this should be our answer for the third example, true, false, true and false. Here also you can see this was the answer. Now let's observe one thing here. While making connection and checking for restriction and all, what we were actually doing, right? So um, the first thing that we were doing is we were simply checking parent, right? Now let us suppose this is our request, right? So we are going to connect 3 with 4. Okay. So first of all, I'll find the ultimate parent of 3. Now parent of 3, or simply say the component of 3. Okay. Let us say this is my first component, this is my second component, this is my third component. Let me write it here. So this is my first component. This is my second component. Sorry. And this particular part is my third component, right? So if I want to establish a connection between 3 and 4, then what is the component number of 3? So component of 3 is third, right? And component of 4 is 1. Okay. Now we have to check if there is any restriction which are having the same component number, right? Like here, if you see the component of 0 is 1 and component of 1 is third, right? So same thing is happening now, because let me just write it here. Um, component of um, 3 was equal to, this was the third component, right? Now component of 4 was the second. So component of 4 was first. Again, this was about my request which I am going to connect, right? Because 3 belong to the third component and fourth 4 belong to the first component. Now I have to check if there is any restriction which shows that first its first element is belonging to the same component and second is belonging to the, like, I mean to say there shouldn't be any restriction where both the element are belonging to the third and first component, right? Because once you find such restriction, so here you are going to connect both of these components, right? So if you connect these components, then obviously that particular restriction will violate, because you are connecting the two different components from which my restrictions element are belonging, right? Suppose in this example, this was the person 0 and person 1. Now person 0 belong to the first component and person 1 belong to the third component, right? Now if I will make connection between any two element from this component and from this component, then definitely I'm just combining both of these components, right? And once both the components are combined, then simply you are violating this restriction, right? So we only have to check the component number of the request we are here with, and we have to check the component number of the restriction we are talking about, right? Now once we find the component number, we are only checking if the components of request and the corresponding component of restrictions are matching or not. And if they are matching, then it is not possible for us to process this request, because we are just combining the both the component which is violating my restriction simply, right? So I hope you got this point. So this is something which we are going to do now. As I told you about here, the component number. So you must have studied in the union find algorithm, where we simply denote the component number by the ultimate parent thing, right? Like suppose this is the component, and even let's say this is my component, right? So we will just choose a node from where, let's suppose my node is 0, and now I will say 0 is the ultimate parent of every node in this component, right? Because if we have to choose only just one node to denote my component number simply. So if I'm saying 0 is the ultimate parent, then the ultimate parent of 2 will also be 0, ultimate parent of 4 will also be 0. So it will be easier for us to determine whether the two nodes are belonging from the same component or not, right? So basically it is same like the component number which I have told you here. So we will be using that particular thing, the ultimate parent. And now if the ultimate parent are matching, so basically the component number are matching. And if component number are matching with the corresponding component number of restriction, then we are not going to process that request, right? So this is something we are going to do. Now this is the union find class of the disjoint set which I have already implemented. I'm not going to write it again because it's going to take a lot of time. If you don't know about the algorithm, then you can just search on YouTube and learn from there. This is just simply the implementation of the algorithm, right? So let's write the code now. Okay, so let us suppose n be the number of element in my request or the number of people, right? Oh, sorry. This the capital N denote the number of people, right? And with the number of element in my request vector. So these are the number of element, and let M denote the number of element in my restriction vector, right? So this will be the size of the restriction vector, right? Fine. Now I will make a disjoint set object which will be of size n, which is denoting the number of people, because how many nodes we want to create, definitely n, because nodes itself was denoting the number of people, so it will be equal to the number of people, right? Now let me make a vector answer where I will be storing my answer, like if it is possible for me to process the request or not. Now let's start with the each request. We are starting from the starting. We are starting from the beginning because it was mentioned in the question that we have to process request sequentially, right? So I should be less than n and I plus plus, right? Now, as I have said, we are only concerned about the parent of the request and the restriction, right? So let's say the parent of the first element of my request is, and this is the request of 5 of 0. Okay. again this is the parent of the second element of my request. Okay, so now we have find out the parent of both the nodes of my request. Now I have to check for every restriction, right? So let's say y be my restriction in the restriction vector. Now I will find the parent of restriction. So this is um, y of 0. Okay, and the another parent be parent 4, which will be like y of 1. Okay, now what I had to check, I had to check if they are just matching their corresponding parents, right? Like if parent 1 is equal to parent 3 or parent 2 is equal to parent 3 similarly. So we have to check if parent 3 is equal to parent 1 या फिर parent 3 is equal to parent 2. Any of the conditions should match, and let me just cover it in brackets. Okay, and parent 4 is equal to parent 1 or parent 4 is equal to parent 2, right? So if anything is happening, then we can say this particular request is not valid or this particular request is violating a restriction vector. So we can say answer should be false. And once I found a restriction is violating by my request, then I'm not going to check for the further restriction, right? Because even one is violating, then this is enough for me to say, yeah, this is not the request we are going to process, right? So we will say valid equal false. Sorry. And we will simply break because we are not going to check for the further. So let's make a boolean which is denoting if we have found any restriction violating or not. So initially set it to true. Now after here, if my valid is true, or basically I cannot find any restriction which was violating because of my request, then I will simply process my request, or I'll say request of y of 0 and should be equal to request of y of 1. Oops, sorry. Okay, so this is something we have done, right? Yeah, so and also I'll say this request is valid, so I just do true here, and at the end I will be returning. Sorry, I have written outside of the loop, so let me just paste it here. No, after this for loop I have to write. And here I will be returning my answer, right? So yeah, we are done. Okay, now let's check if it's working fine. Where is RU? UST, it should be. Okay. Okay, so it's working very fine. Let me just submit it. Yeah, so it's accepted now. So yeah, guys, it was the entire solution of the question. Now, if you have any issue or doubt with the problem, you can ask in comment box. I'll resolve it out. Also, if you have any question which you want me to make video on, then you can also suggest in comment box, right? So thank you so much for your patience. Have a good day.